So our next speaker is Dr. Renee Weber, who was the chair of the Artemis 3 science definition team, and she has the unenviable task of summarizing that multi-month effort in 10 minutes. Take it away, Renee.
Thanks, Kelsey. Just real quick, can you confirm that you can hear me all right?
I can hear you great, loud and clear.
Fantastic. All right. Thanks for having me and for the opportunity to present yet again our Artemis 3 science definition team report. Many of you have likely already seen some version of this presentation or attended some of our public town halls while our activity was still active. So I will try to retell the story afresh. And of course, I have tailored my conclusion slides to this audience and to this workshop. Next chart. So everyone knows Moon enables scientific exploration, and we've been having this series of workshops to talk about that explicitly, so I don't think I need to explain that to this audience. Next chart, please. So I will dive right into what the science definition team did. So the science definition team was chartered by Thomas Zurbuchen for NASA SMD, and the committee was charged with defining compelling and executable science objectives for the Artemis 3 mission. After we concluded our activity, we did submit a final report to the Planetary Science Division, which contains prioritized science objectives for all aspects of the mission. The report was submitted on November 13th, and it was released publicly on December 7th. Next chart. If you haven't seen it, I recommend you check it out. It is available at nasa.gov/reports. Next chart, please. And so one thing that I want to point out is that our science definition team very much did not operate in vacuum. Obviously, we aren't the first folks to have thought about science to be done on the surface of the moon. And all of our objectives, goals, and investigations were drawn from guiding documents that have broad community support. Among them are the League Lunar Exploration Roadmap, the National Research Council's SCEM report, Scientific Context for the Exploration of the Moon, the 2018 sort of update on the SCEM report chartered by League called Advancing Science of the Moon, and finally, the most recent Planetary Decadal Survey. But almost as importantly, or maybe even more importantly, we also drew heavily from the approximately 126 community-submitted white papers that were solicited specifically for this activity, and which I'm sure many of you participated on, as well as comments that we got back on public draft versions of the report that were released as we were going through the writing process. And I thank everyone that participated in that process because it provided extremely valuable feedback to the report. Next chart, please. So the process of traceability from objectives down to investigations drew from the 7 science objectives that are actually existing in NASA's Artemis plan. If you haven't seen those before, those are understanding planetary processes, understanding the character and origin of lunar volatiles, which is especially important since we are planning on a polar landing site, interpreting the impact history of the Earth-Moon system, revealing the record of the ancient sun and our broader astronomical environment, and observing the universe and the local space environment from the moon as a platform. And then also 2 objectives focused more on exploration. One is conducting experimental science in the lunar environment and also investigating and mitigating exploration risks. So the SDT was charged with expanding upon these objectives, and we did that by mapping science goals, which are areas of research, down to specific investigations, which are activities undertaken to address the goals. Next chart. So through this activity, the team constructed a candidate science program to capture the highest priority science for Artemis 3 and provide the greatest feed forward to follow-on missions building up to the eventual Artemis base camp. So this is a cohesive program. It contains a mix of activities that are likely very familiar. The first is field geology and sample return, and the second is in situ measurements and long-lived experiments. And these sort of three prongs of the candidate science program are, the priority of the types of samples and the types of investigations are listed here. But one important thing to note is that a more detailed mission operations plan that is based off of this program will need to be developed by NASA when some of the Artemis architectural details come into sharper focus, the most important of those being the actual capabilities of the human landing system, as well as the final landing site. Next chart, please. So the Science Definition Team report contains 15 major findings and accompanying recommendations made to NASA with actions to address each finding. I won't have time to go through all of these in detail in this short time, but they are sort of broadly encompassed by these categories here: crew training, coordinated sampling strategies, enabling capabilities, which encompass needed technology developments, actual program architecture recommendations, science implementation strategy, cartographic considerations, and finally, some science inputs to landing site selection. Next chart. So to this audience, I would like to highlight a couple of the recommendations that are relevant to the purpose of the workshop. The first focusing on crew training. So astronauts should participate in an Apollo-style course, both in geology and planetary science, and I think we all know that courses like these are currently underway. This would include both field and classroom components in order to provide optimal in situ geologic characterization of lunar sample collection sites, so echoing some of the comments that Jack made right before me. And most importantly, a dedicated team of scientists should serve in an Earth-based Artemis 3 Science Mission Center with real-time two-way audio and one-way video between the crew and the Science Mission Center. So those that support capability will maximally enable science on the surface. Following from that, the report recommended that astronauts should also be trained and equipped to collect a variety of different surface and subsurface samples, and that NASA should plan to return total sample masses in excess of previous lunar sample return missions. Next chart. Building from that, the report also recommended that NASA should ensure that sample collection and in situ measurements are carefully choreographed, which also maximizes science return. And some examples could include characterization of rock samples with in situ handheld instrumentation to aid in prioritization of samples selected for Earth return, as well as in situ volatile measurements that can be made in conjunction with sample collection to characterize volatile loss from the collection, transport, and curation process. This can also provide ground truth for orbital remote sensing data sets. And secondly, NASA should ensure that in situ imaging and assessment capability is also available to crews during EVA to document site characteristics, sampling, and instrument deployment. Next chart. So a related recommendation is one of the enabling capabilities that would help serve this real-time science support capability, which is related to data transfer. So the SDT recommended that NASA provide a mission capability of real-time transmission of data, both from the in situ science instrumentation and the video and audio feeds themselves. So that is the technology that enables a science support team, a back room or an operations center that can support the EVA with feedback to the crew when necessary on science decision making. Also can help convert raw data into tactical products for decision making. So this requires a prior establishment of high bandwidth communication that is capable of extensive real-time data transmission to accommodate use of those measurements from the modern sensors on the moon. And I do think that is my last chart. Of course, like I mentioned, there were several other categories of recommendations made, and I encourage everyone to check those out. The executive summary of the report right up front contains all those recommendations, And if you dive further in, you can find a lot more detail on the candidate science program, sample collection, in situ measurements, and deployed activities that were deployed experiments or investigations recommended by the team. So thank you, everyone, and I will be sticking around for questions later.
Thank you very much, Renee. That was great. I think a lot of those lessons learned that you mentioned have a lot of applicability toward the goals of this workshop, and a lot of those topics will come up, I hope, in the breakouts in more detail. So thanks for setting the stage so well for those.
I just saw as you flashed, I did have one more
Sure.
slide, the last slide, just thanking the members of the team, including Kelsey, without whom we would not have been able to do this. So thank you again.
Great. Thanks, Renee.